Here we go. Protons, neutrons, electrons. Oh my. Welcome to a podcast about atoms. So we are basically counting protons, neutrons, and electrons in this episode. Here I have two elements. Here's carbon, here's lithium. When we write these elements, we have two different forms. We have what's called symbol form, which follows a format like this, and we have isotope form, which is essentially we write the name. Now, when you're looking at this format right here, this right here, that part, that goes the element symbol, goes there, all right? That number right there is the atomic number, and then the atomic mass goes there, and then that is usually a plus or a minus, and that is charge. All right, so if I take my carbon right here and I want to write it in symbol form, I write my element symbol, my mass goes on top, my number goes there, and then whatever charge it would have would go right here. If there's no charge, it'll just be blank. If there is a charge, like a plus or a minus, it will go in the top right-hand corner. Now, most elements have known charges, but charge can also be adjusted based on the electrons, which we're going to talk about next. All right, let me move on to lithium here. Now, moving on to lithium here, if we were to write it in symbol form, this would be lithium. The atomic number goes down there at the bottom, and the mass goes at the top. We use rounding rules, so normal lithium has a mass of 7, and it has a charge. Lithium's normal charge is a plus 1. All right, and this is how we would write it. If we write it in name form, then it's, just write the name lithium dash and the mass. There are lots of different types of what we call isotopes, which are basically the same element, but they have different masses. So you could see lithium 7, lithium 6. Lithium 6 would be like this. And that's just how we notate the differences. Okay, so counting protons, neutrons, and electrons. That right there, that is the atomic number, once again, and that is the mass. Okay? All right, so as it turns out, protons are gotten from the atomic number. So protons, which are positive, are directly affect the atomic number. Neutrons are usually mass minus the proton number. So in my lithium example right here, this particular lithium, we'll just use lithium 7. If it weighs 7 and 3 of those are protons, minus 3, that leaves me with 4. That means that lithium 7 has 4 neutrons. If I have lithium 6, that means lithium 6 weighs 6. It has 6 total protons and neutrons. 3 of them are always protons. Then that means I have 3 neutrons. Okay? Now, for our purposes mostly, proton number is going to equal electron number unless there's a charge. Now, let's look at this one right here. This is lithium 7, all right, and I've drawn it for you over here to the right-hand side. It has 3 protons, 1, 2, 3, and 4 neutrons, 1, 2, 3, 4. That's why it weighs 7, all right, and then normally protons equal electrons. Now, the electrons are the negative part. So if I take away one of these electrons right here, then that's going to give me a positive feeling lithium. And that means my lithium electrons, protons equal electrons, that they're no longer equal. If I take away one, now there's only 2 electrons. So that means that this lithium is a positive 1. It feels 1 positive. There's 1 positive thing outweighing the negative thing. Okay, so let's kind of sum all of this up. Protons are positive and they equal the atomic number. Neutrons are neutral and they equal whatever the mass of the atom is minus the proton number. And electrons are negative and they equal protons unless it's charged. If it's a positive charge, you are going to subtract. And if it's a negative charge, you're going to add to that number. Okay, so let's try some examples. I'm going to work out a couple of examples just to show you the hierarchy of rules here. And I put the elements down at the bottom just to make things quick and simple. Now, let's go ahead and look at number 1. Number 1 says that its atomic number is 12. Well, the atomic number makes the element, and so this is magnesium. If its atomic number is 12, the atomic number always equals the number of protons. And for our purposes, protons equal electrons. But in this case, this magnesium has a charge. It's a +2, so that means you're going to subtract, and it has 10 electrons. Now, how we find mass is that this mass number is the total number, how we find neutrons is that this mass number is the total of protons and neutrons. Well, if 12 of them are protons, and the thing weighs 24, then that means the other 12 are also neutrons. You get the average atomic mass off of the periodic table, so you have to look that up. And when you look at magnesium on the periodic table, you get 24.305. And so in symbol form, we would write a 24 on top, a 12 on bottom, and then the 2 plus goes in the top right-hand side. And in order to give it an isotope name, we would write out the word magnesium. Usually you'll see a little dash and then the mass, which is 24, and really hard to do without an Apple Pencil. Okay, let's try another one. All right, number 2 here says that it doesn't give us an atomic number, a mass number, but it says that it has no charge. And if it's no charge, then that means there's no difference between the electrons or the protons. So it has 26 protons, which means its atomic number is 26. When you look on the periodic table, number 26 is iron. Okay, that atomic number is going to go down there. And we find the mass by protons and neutrons. So there are 30 neutrons and 26 protons. When you add those together, you get a mass of 56. And so the 56 goes on top. So we have iron 56. All right, and you get the average atomic mass off the periodic table. It's 55.845. All right, the next example 3 is also iron, but this is an isotope of iron. So these two are the same element, but they're isotopes. That means they have a different mass. And because they have a different mass and they're still the same element, they do have the same number of protons. If I change protons, then I change the element. So what's different about the isotopes is the number of neutrons. And since this iron weighs 57 and 26 of them are protons, that means I have 31 neutrons. Now this iron has a charge, and normally protons equal electrons. But this element has a positive 3 charge, so we're going to subtract, making it have 23 electrons. And so in symbol form, we would write that as 57, 26, Fe, and then the 3 plus goes up there. 7. All right, and again, it's going to have the same average atomic mass because we get that off of the periodic table. All right, number 4. Now this one's a little tricky. This one it doesn't give you a lot of information. It says it has 1 electron and 2 neutrons. If you don't know how many protons it is, how are you supposed to know what element it is? Well, it says that it has 0 charge. So that means protons equal electrons. So this is atomic number 1. And atomic number 1 is hydrogen. So this is hydrogen. All right. Now its mass number is protons plus neutrons. And so we have 3. 1 proton and 2 neutrons. So next we look at the periodic table, and it's 1.008 for that. And so I think that we're done. So this is hydrogen 3, and I'm going to write it down here. We would write it as a 3 there, 1, hydrogen, and then it has no charge. It has 0 charge, and so we leave it there. Leave it just like that. All right, the next one also has 0 charge and 50 protons. And so that is 10. Its atomic number is 50. Protons and the atomic number are equal. Now, normally protons equal electrons unless there's a charge. There is no charge, so he has 50 electrons as well. His mass number is going to be the addition of the neutrons plus the protons. So 72 plus 50 is 122. And so I'm going to write this part down here. We would say this is the isotope of 10, 122. In symbol form, it would be like that, right? 122 up top, and its proton number or atomic number down at the bottom. And so we would get the average atomic mass off the periodic table. Okay? So before we move on, I want you to know how to write it if it has a charge on it. So I'm just going to take my magnesium right here. I'm going to come down right here, and I'm going to rewrite it. This is magnesium 24. All right? So the mass number goes on top. Its atomic number goes at the bottom, and then its charge would go to the top right-hand side. Inside of your packet, you have the notes, which I've just done with you, and then you have the atomic structure practice. This will allow you to practice all of the different hierarchy system of getting all of these different numbers here, protons, neutrons, and electrons. Just remember one thing, how to get protons and how to get neutrons and how to get electrons, okay? This number right here comes off the periodic table. And this number right here means that it's the same elements, but it could have different masses. So down here at the bottom, it's going to ask you, after you fill in this chart, you know, are there any isotopes on the chart? And if you see, if they have the same atomic number, but they have a different mass, then they are isotopes. I know, my chemistry students, that you have been working so hard, and I just want to say thanks for being great.